I'm busy doing a 4-year review on a big weld up at Artec, and I'm just going to cut some scrap up into some plates to do some test welds on. And I thought I'll write the thickness of the plates on just to give it a bit more professional look. This is 2mm plate. I want to do 2mm, 3mm, 4mm, and I think I've got some 6mm. And the idea is to try and sure how to set the welder up with regards to wire feeds and voltage. I've got a sketch here for a pipe thread adapter made out of mild steel. It's basically 1.25" BSP outside with a 3/4 BSP inside. I've printed off the BSP pipe chart so I know what diameters I'm measuring and working to. 1.25" gives you the outer diameter, and it gives you the inner diameter, which obviously that's going to be the size of the hole you bore if you're going to put threads inside a hole, and that's the size the material needs to be to put threads on the outside. It's 11 TPI pitch. I can cut 11 TPI on this lathe by changing some gears around. I've got a piece of decent mild steel bar there. I know it's mild steel bar because the lad that supplies me with my bar ends writes on what they are. So that's what we're going to start making first. The first thing I'll do is the 1.25" BSP thread, because that's where the most chances of something going wrong are. It's pointless doing everything else and doing the thread last and making a mess of that. So we'll set this up, skim it, turn it to the diameter for the 1.25" BSP thread, and then put some threads onto it. Sizes I've been given are all imperial, but I'm going to convert them all to metric. It's just easier on this lathe. Plus the sizes for the BSP on the chart are actually metric as well. This should take it down to exactly 2 inches for the outside. It's the diameter for the thread that's an important one. So I've lost the surface finish because I put a lighter cut on. You need to push hard to get a good finish with carbide on mild steel. Right, so that's 2 inch. Next I need the thread diameter turning down. The size we want is 41.9, so I've set the caliper at 41.9 and zeroed it, and that'll give us a direct reading how much I need off, and we need 9mm off that, which is 4.5mm a side. We're going to go down, it says 1/2 inch, but I'll do a little bit more, then we can always clean the threads up. Touch this off, set the 0 on the cross slide, the DRO cross slide scale's not working in a minute. I'll put a 1mm cut on, that'll take 2mm off altogether. that's 8mm I've taken off. We need 1.1. Take the one off first. That's blob on size. Zero the vernier. Measure it again. And I've got 41.9, which is exactly what I need. I'm just going to put a little lead on the end of it. Nice little chamfer. We've got a little bit more than a ½ inch, so we can always trim the end down. I'm going to set the gearbox up now to cut the imperial thread. Once I've done that, we'll turn the camera back on. These are the gears in the back of the lathe. That's the lathe spindle and that's the gearbox down there. And these two gears here, that's a 63 tooth and that's a 40 tooth. That's the conversion between metric and imperial. Sometimes use a 127 and an 80, but you can't get a 127 in here. I actually made the 63 and I made the 40, so that's the gear train set up. It's noisy, straight cut gears with a little bit of backlash on them. You don't want them too tight. That gear there's a fibre gear. The idea is if something goes wrong, like you crash the lathe, it'll strip the teeth off there before it does any sort of major damage. A little bit of nice heavy oil. This is actually Sentinel steam wagon crankcase oil, real sticky, lovely stuff. Right, I've got the gearbox set up to cut the 11 TPI. That's a Whitworth foam tool, 55° foam tool to cut 11 TPI, so make sure that's nice and square to the job. I know it's on centre height. I'm going to feed direct in, straight in, that's what these tools are designed to do. We'll start things up, touch things off and take a cut and have a little bit of measure. I'm going to run the lathe really slow, slower than that. Once I start to cut this thread, I've got to leave the lead screw engaged. I'm going to put a little bit of layout blue on here so you can see the scratch cut. Isn't that a beautiful colour? I like a car, that colour. Touch it off there, zero the compound slide, and I'll know how much I've got to wind the tool in until the thread's cut. So a little bit of cut. Engage the feed screw. First the lathe. Right, thread gauges, and we'll have a little bit of a measure just to confirm it is cutting 11. Looks good to me. There's now it seems to speed up when you get towards the end. Unfortunately I missed the last pass, but that is now a nice clean sharp thread and it measures up pretty good. Next is to drill this and put a 3/4 BSP thread through there. I've got a 3/4 BSP tap, so that should be relatively straightforward enough. .5mm as a tap and drill size will require. Might have to bore this to finish size because I haven't got a drill the correct size. Put a boring bar through there and whip it out to 24.5 and go from there. I'm running a nice little high speed steel boring bar just to take the hole out to 14.25, which is the correct size for a 3/4 BSP thread. .28, that's certainly going to be well within the bounds of acceptability. I'm going to wind this tap in by hand. It would expect a lot for a tailstock chuck to grip that on a small lathe like this or a middle-sized lathe like this, and I haven't got a collet AR32 big enough to hold it, so I'm just going to use the lathe centre to keep it nice and square, and we'll just gently wind it in by hand. Once it's started nicely, I may even take it out and put it into the vise and use a big tap wrench to wind the tap through, because it is going to be pretty tight. In fact, that's what I'll do. It's well started there now, so we'll finish the thread off in the vise. It's not the best tap in the world, but it's the only one I've got. Right, so it's well started there. Right, this is not funny at all. It's a sort of manual hydraulic. Really is putting the thread in, nevertheless. Just about there now, I think. Greenfield number 7, really nice tap wrench. Was sent in by a viewer. I don't use it often, but when you use it, it is nice to use. Adam Booth always raves about Greenfield tap wrenches, and that's the reason why they are good. use the end of the part to make sure that the parting tool is at 90 degrees to the job, and all you do is set on centre height. Just check the distance from there to there. Just getting issues with the bottom of the tool holder, clipping the jaw because the bottom of the tool holder sticks out slightly further than the top. So I'm just going to put the tool through a little bit further. You need a little overhang that you can possibly get on a parting tool to try and keep things nice and rigid. Get a gentle grip on this. All I want to do was reface that face there and put a nice little chamfer on it. It won't 100% true, but it doesn't really matter because we're finished doing the threads. It just wants one final pass through with the tap to clean them up. Once again, just had to say thanks for watching, thanks for subscribing. If you haven't subscribed, please click the button, it is important. Anyway, thanks for watching.